Supercritical carbon dioxide Brayton cycle test loop facility developed by Indian Institute of Science is the next-generation power plant which uses CO2 as a working fluid. High density and great thermal properties of CO2 makes the entire system extremely compact and efficient, unlike the conventional steam power plants. A number of novel control techniques are also being devised to allow stable operation of SCO2 system, particularly for waste heat recovery and concentrated solar power applications, where source temperature can vary significantly. IISC Bangalore along with Triveni Turbines is working on host of applications, which could benefit the utilization of SCO2 technology. These include waste heat recovery for cement and steel industries and bottoming cycles for gas turbines. In this regard, number of patents have been filed, which include new thermodynamic cycle for waste heat recovery, which perform 12 to 15% better in terms of output power than the current SCO2 cycle for waste heat recovery. In addition to power cycle, IISC is also developing transcritical CO2 refrigeration technology using CO2 to replace synthetic refrigerants. This technology is expected to be combined with the SCO2 power cycle to get required cooling and power. The realization of SCO2 technology comes with a lot of challenges. Compact turbomachinery is one of the key challenges, due to its very high operating speeds of 40,000 to 150,000 rpm. Rotordynamics, sealing, manufacturing, all of which makes an engineering nightmare to realize the technology at small scales. The impeller of a centrifugal compressor for the test loop is as small as the size of 10 rupee coin and spins at 70,000 to 80,000 rpm. Design and manufacturing such small impeller diameter has been a challenge. In addition, there are no availability of high-speed generators or motors, which also had to be indigenously developed for the test loop. This work is done in collaboration with the Electrical Engineering Department at IISC, which has successfully developed high-speed switched reluctance machine for the test loop. The compact heat exchanger, commonly termed as printed circuit heat exchangers, or PCHEs, offer very high cooling capacities in a small footprint. They are also highly efficient compared to shell and tube heat exchanger. A PCHE comprises of alternatively stacked hot and cold plates on top of each other. IISC is working with NFTDC, Hyderabad and BHEL Vishakhapatnam to indigenously manufacture these heat exchangers. Few prototypes have been built and currently being tested for high-pressure, high-temperature applications.